Okay, hello YouTube. Today what I wanted to be able to show you is how I built my very own powder coating gun. You may not necessarily think it's much to look at, but I think it works brilliantly because I was really surprised with the particular results that I got. Now I reckon I probably built this, let's say for about $20. Let's say it's always very difficult to be able to quantify some of these particular costs because there's those things you already have and what you source for cheap, etc. So I'll explain each step here. This particular high voltage module box that I built cost me about $9, but that's only because of the two particular components inside. The particular powder coating gun here, this is just a plastic bottle and a bit of PVC. I already had one of these particular gun handles, but you can pick those up for $10. I haven't included that in that particular cost. And this particular plug pack that powers this particular unit over here, I had from an old modem, internet modem. So let's say for about $20 here, give or take, you can make a pretty awesome working gun. I've seen online cheaper guns going for about $180, so I'm pretty chuffed with this build. But before I get in and show you how to actually build it, let me show you it in action and the results I got, and then I'll step through each component. Okay, so let's start looking at what's inside this box and how to build it. Now, I really think this is just the smarts of this particular setup. It's not really that complex. I was quite amazed at how simple this particular box was actually to create. Other than the input plug that I picked up so I could plug a plug pack in without hardwiring it in, and this particular switch, the two components inside here cost about $9 to be able to make. The box itself is just an old junction box that I had, electrical junction box that I had lying around from some previous work I had done around the house. And I just put two little bits of wood on there just to be able to do it on the cheap. These wires here, I think I saw some from an old washing machine. I just pulled out these particular wires. And I've tried to be able to keep all the colours consistent so you can actually be able to see how it all wires together. So this particular wire is the positive. Now this attaches to the gun itself. And this is the negative wire, and I attach that to the workpiece. So let's describe what's inside this box. Now it's really quite simple. There's actually only two modules in this particular box here. Now this first module here, this module I think I picked up for about $5, $5.20 or so, and I bought this from China. This is a taser module. Now what it says on the particular the ad is that you can put in up to 7 volts on this side. We'll only be putting 4, and out that side when you do 7, you can get 400,000 or 400 kilovolts out this side. So I don't have the instruments to be able to measure what I'm getting off here, but you'll be able to see some sparks flying in a moment. Now, what I initially did when I did this was I set this particular module up on this bench power supply here, and I was just feeding, I think it was 4 volts in here, but I blew up the first one. And I think what happened there is that these two wires, the high voltage wires, are touched at some particular point. And when they do touch, a flood of current comes through this module, so high amps, and it destroyed itself. So what I then did is I then purchased this particular module here. So I think I got this for about $3.50. So together I think these two are about $9. Again, from China, I bought a number of them. But what this is also known is known as a buck converter. So essentially what that does is steps higher voltage from this side down to a lower voltage on this side. Now the thing is that with this particular one here, it's got another special feature in that it also limits the current coming through. So they use them for lithium battery chargers mainly. So what happens here is on this one here, I'm going to supply 12 volts on here. We're going to limit it to 4 volts and 2.5 amps to coming out this particular side. So here's that yellow wire and blue wire. The yellow runs into the positive red wire on this particular module, and the blue wire, or the negative on this side, runs out onto the green wire here. So the thing that then what I do here is I follow the red wire through, and I assume that on this particular side, which is the side closest to the camera, is the positive wire. So I've attached a yellow wire from the box on that particular side, and that then goes off to the gun. And then I attach the blue wire to be consistent here, and that goes off to the workpiece and those little clamps. So I guess there's nothing more then to show you than this particular thing in action. So if I just power it up, it'll be noisy for quite a sec, but what you'll see is a jump of a spark across there. All I've done here is taped it up with a bit of masking tape at a gap of 1 centimeter to be able to show that high voltage. So if we power it up, wow, that's really loud. So the reason that it's doing that is because they are so close. Schools here use these for high voltage modules to be able to show these arcs at that particular and what it does, ionizes air, etc. But what we can use it for is to be able to ionize the powder as it comes out of the gun to be able to then cling to the workpiece. So let me show you how to configure this particular module. Now these little modules are actually really easy to configure. What you'll need to be able to do that though is a multimeter here. And I'll talk through, if you've never used one of these, I'll talk through the various settings you need to put it on to be able to configure this thing. I'm also going to use my variable bench power supply here because I want to be able to vary the voltage to be able to show you one of the features of this little board. The other thing you'll also need is a load. Now what I'm using here is an old CPU fan. What you can see here is that it's 12 volts and it runs at about 1.9 watts. Apologies for it being upside down. It just was easier for me to configure it this particular way. Now this particular board here has a couple of features. So here's one that's actually a bit closer. So on this particular side here, this is where I put in the red and the blue wire. So the red wire here is from your power source. So in this particular instance, I'm going to run it on my variable bench power supply at 12 volts. So it comes in here. This is where we'll adjust the voltage in this first particular pot here. The second one here is where we'll adjust the current, and then we'll get the output voltage of 4 volts and 2.5 amps out this particular side. So to be able to configure it, let's turn on our bench power supply here. So I'm going to run it up to about 12 volts here. So you can see the particular needle moving up and you can hear the fan going. Now what I need to be able to do is to be able to see this voltage on this side lower itself down. So what I've done here is on my particular multimeter here, I'm going to connect this red wire, which is over here on this lower voltage side, and I'm going to turn it round to 20 volts DC measurement on this particular side, and I'm going to clip, see how I've got the yellow wire coming into this particular clamp here and run into the positive side of this little fan. So I'm going to put the positive or the red wire on here, and on this side this is where I've got the negative wire joined on. This is on the output side, and I'm going to join it here. So what you should see is it leaps up to 12 volts up there. So now what we're going to be able to do here is take this little tiny screwdriver and put it down onto this first little pot here. We're going to start turning it in an anti-clockwise direction. So what that will now start to do, it may take a little while because they're always set when you receive them right up to sort of full voltage. So what we're going to do is we're going to just start twisting it in an anti-clockwise fashion until the voltage starts to be able to drop. Now you'll start to hear the fan, see the fan here, hear the fan, the RPMs is changing here. So I'm just going to keep going until I take it all the way down to 4 volts. keep going. So it doesn't have to be spot on, but we'll just take it to about 4 volts. So that we can throttle that taser module. So I'm pretty happy with that. Okay, so now what we're going to be able to need to do is now set the current. Now the reason that we're setting the current is, should the 2 wires or your workpiece and the actual gun touch, you can actually short the particular circuit out. You'll throw too much voltage or too much amperage in there, and that module will destroy itself. So what this next particular feature here is to be able to now turn to limit the current here. So what I'm going to do is I've turned off the bench power supply, and this thing here is now is still running in parallel. But what I'm going to do is we're actually going to short it out. So what's going to happen here is this fan is not going to spin, because all the current is going to come through here, up into the multimeter and back, right? So to be able to do that, I need to reconfigure it by switching this particular plug over onto the other side, over to the 10 amps, 10 amp fuse side, and now switch this all the way around to the amp measuring setting. So in here you can see 10 amps. Hopefully you can see that there on the screen. So when I turn it back on, you should see that it leaps back up to, about 5, oh there you go, about 6 amps, right? And what you might not be able to see is that there's actually 3 LEDs on these particular modules. So on the particular module here, you can see that there's a red, a blue, and a green LED. So back over here, you should be able to see that the red LED is a light. And what that's saying is it's holding back the current at 5.7 amps there. So on this second pot here, we're going to now turn this in an anti-clockwise fashion, and we should be able to see that the current start to drop again. So we can see there as it's 5, and now I'm going to take that all the way down to 2.5. Because that's the limit that I've found that these particular modules seem to work really well at, and they don't seem to destroy themselves under this. So as I bring it all the way down, I'll turn a bit quicker, all the way down, getting closer. And there we are. So now that's set to be able to have it so that it's limiting the current. Notice again that this fan isn't spinning because all the current is going this way into here, and this is essentially where all the load's being measured from. So now here what I'm going to do is turn that off, and to be able to now go back to this particular setting where I'm measuring the voltage. So back around up here to the 20, and I'm going to turn it back on. So this is that feature that I wanted to be able to show you. So this is now spinning quietly because it's now running at 4 volts, but it's not limiting the current because this thing draws hardly anything. Now what is really interesting here is what's great about this, as long as the voltage on this particular side here is higher than the output voltage here, it will maintain that particular regulation. So for that module I've created, I've just used a modem, a power pack from an old internet modem past here, and this is what I'm using to be able to power my powder coating gun. So what you can see on here, you should be able to see here, is that the output here is 12 volts and at 2.5 amps. So what you need to do is, if you're going to select one of these particular plug packs, you need to ensure that it's either 2.5 amps or greater, because this is what we're running it at here. But it's running here at 12 volts. But what happens if you've got a 3 amp plug, let's say, but at 10 or 15? So the sense here is we should be able to see, if I can get it to focus here, is that with this particular module, see I've got it at 4.04 volts. Even if I lower it, so I'm going to go down, you should see the needle go down to about 6. But see, look, it's still at 4 volts. And again, at the same time, I can take it up to about 15 or even, let's push it even right up towards the red. So that's 24. So what this is actually doing is maintaining this little fan at 4 volts, regardless of what the voltage is, provided it is higher than 4 volts, and it doesn't exceed the vendor's recommended voltage input. So that's how you configure this particular module. All right, I guess all that's left to do is to actually talk about the gun itself and how I made it. So the gun is really just a reusable bottle, some PVC fittings, and this particular handle here. I think, as I said earlier, you could pick one of these handles up for about $10. You just unscrew the fitting that comes with it, and you can fit this 1/4 inch fitting in there. Okay, so let's start with the bottle. The reason I chose this particular bottle is because of the tapered neck that it has here. What I found when I used a peanut butter jar, etc., with an inlet and an outlet, it created too many eddies. So when I use this particular one here, what I find is really great is you having this particular rod here holding the tube into the center of the bottle. It then sort of puffs it evenly, goes around the edges, tapers up and through, and then exits the gun through the electrostatic chamber. Now the other thing that's really useful about using these particular types of bottles is that you can actually buy a number of them. And in so doing, you can store your powders in them without having to swap them around and clean them out, etc. So here is the powder that I used in that particular video at the start. I just store that in my shed. And with the other bottles, as I get various different powders, I'll store different powders there. And when I need it, I'll just plug it on, use it, take it off, and put it back and clean the gun out, ready for another color. Okay, so this particular tube coming down is nothing more than just clear vinyl tubing that you can sort of pick up from a hardware store. It's 6mm, and the particular rod here that I have is just an aluminium brazing rod that I had. And all I've done here is I've just sort of hooked it over, and it comes down. So I've created a little hook and drilled a hole there. And all that is to be able to do is to hold it straight so that it sits about the center of the bottle at the bottom. And I've just used electrical tape to be able to tape that on. I'll see how that goes. Now, you may have actually bought before one of those 21 sort of Nitto pieces for your air compressor. And what tends to come with them is one of these little tiny 1/4 inch male-to-male fittings. And that's all that is up here at this particular head here. So this is just is 18mm pressure PVC, and this is just a cap and a T-junction. That's all you really need. So all I did there was drill a hole in the top of this particular cap, and it's just a bit smaller than the threads here. And as I worked it on, it tapped itself. And because you were running such low PSI here, or just low pressure, it causes no problem. It doesn't seem to cause a problem. So I did put some Teflon tape on here to be able to stop this particular side of it, and then being able to then fit it onto this particular piece. What happens is that the 6mm just presses itself on quite easily onto this particular one here. I just thought I'd do it ahead of time so you didn't see me struggling trying to be able to do that in this video. So all that happens here is that connects up to the cap, comes up to that T-junction, and then heads down in this particular direction here. Now to stop the powder as it's starting to come up and exit the gun, sort of pooling back here and sort of clumping, all I've done is I've created inside there a little tiny tapered silicone. I've just injected silicone there, and I used a paddle pop stick to be able to smooth it around to be able to create that particular concave exit, so it comes up back this way. It does get a bit of powder on it because it is a bit sticky, but I've only got one powder at the moment, so we'll see how that goes. My particular thinking is I can change this gun configuration a couple of times over, because the actual sort of smarts of this unit is that high voltage box that we configured earlier. So as I pull this off here, this is actually the electrostatic chamber, and all it's got here is again 18mm PVC, and it's got I just happen to have a bronze brazing rod that I decided to be able to use here. I just drilled a hole in the top here, and I've got it as an L. I'll pull this out in a second. But I've just got an L here, and this is where I clip on the positive clip of that high voltage module. So I've got little alligator clips on there. I just clip it on here, the yellow or the positive side, and this then creates, it robs it of the ion, so it's charged as it comes out and then clings to the workpiece. So you have to connect the blue wire to the workpiece itself. So all that happens here is you can see down there, I'm just going to pop this down and out so I can show you what this thing here is. Okay, so it's nothing more than just a bit of PVC pipe, and what I've done here is this is the aluminium what's this, bronze brazing rod. So all I did here was just bent it 90 degrees so that it could actually fit nice and easily down there, so I can then find that hole and then push it through. And I just got some other little bits of it, cut it off, and created these little tiny U's, and so that they were at the width of this particular pipe. And so it's just with a bit of pressure against it, and I've just silver soldered those on here. I'm sure I could have done that better, but it works. It sticks nicely there. So when we actually then push it through, you can see that it just sits and it sort of holds nice and firm there. So the two, so that it can hold up here at this particular point there, and then attach into that gun. So that is in itself a very simplistic explanation with regards to the gun and how the gun works. So put it all together, it's a rather cheap setup, and it seems to be getting some really fantastic results. Please leave me comments. Don't forget to like the video if you think it's great, and I'd love to see the things that you've created with this particular gun, and let me know of your success or your failures. Take care.